Alright, let's look at part 2. F of x equals -1 times the sine of x. So let's go back to our calculator and change sine 4 sine x to make that a -4. We're going to insert a negative. Make it -4 sine x and graph it. What change do you notice? Now, as opposed to the graph starting up, now it starts by going down. So that is reflecting across the x-axis. Just like the other functions that we discussed, be it absolute value or quadratics most recently. So we have f of x equals the sine of x plus d. So now let's go change y2 again. Or y equal, we're going to change y2 and make that sine of x. And let's add 2. We'll hit graph. And what do we notice? The entire graph did what? It moved up 2. So, did it change the x-intercepts? Did it change the x-intercepts? Let's look at our graphs. Did it change where it crosses the x-axis? Yes, because clearly on the second one, it does not cross the x-axis. Okay, it changed the y-intercepts. So now instead of crossing at the origin 0, 0, yes, it is now crossing somewhere differently. So yes to that as well. Does the domain change? Nope, that is still negative infinity to infinity. Did the range change? Well, because the whole graph moved up, then yes, there is a range change. And what are the domain and range? So the domain stayed the same, so it's still negative infinity to infinity. But now, since the entire graph moved up 2, our range now becomes from 1 to 3. Alright, so now, let's look at cosine again for a moment. So we'll make y1 cosine x. And we'll clear y2. And let's change our window again to make that x from 0 to 2 pi. And we'll keep it scale, and let's move our y back to negative 2 to 2. And graph and see what we come up with. So what do you think is going to happen if we put a value in for a? Do you think it's going to be different or the same as compared to when we did sine? So if we did 3 cosine x, It's a little different, right? It's stretched. So A is still gonna give us a stretch or compression. Remember, if A is less than 1, the absolute value of A, not looking at negative or positive. If it's less than 1, then it's going to compress and get wider. If it's greater than 1, it's going to stretch and get slimmer. D, what do you think the value of D is going to do? So if we go back, let's say cosine X. Let's add 1. Wrap it, see what it does. D again does what? Moves everything up 1. So that is still going to be our vertical shift. Plus, it's going to take it up. Minus, it's going to take it down. So put in -2 cosine of x plus 4, which is going to require you to make some changes to your window. So let's make this -6 to 6, just so that we have enough room. Y equals -2 cosine x plus 4. Right. So notice again how that shifted. Instead of starting down, it's now starting up because it flexed across the x-axis, and everything rose because of the plus 4, and you had to stretch with the 2. So now our domain, we're starting at 2, 4, 2, 3, 4, 5, 6. Okay, so the domain is still -infinity to infinity, while our range is from 2 to 6. So on this last part, we want 4 values for x in radians for which sine is -1. So you can go back and see where sine is -1. 3 pi over 2. So think coterminal angles. So if we take 3 pi over 2 and we find the coterminal angles, name 4 of them. We got 3 pi over 2. We're going to have 7 pi over 2. We're going to have 11 pi over 2 and 15 pi over 2. We want 4 values for cosine of x is a half. So again, we can go back and see where's cosine of half, if you don't know off the top of your head. Starting with pi over 3. Again, think coterminal angles. But we go back and look for a moment, because cosine is a little different. We said cosine is a half. We got pi over 3, but because of the way it cycles, we also have 5 pi over 3. So our coterminal angle to that is 11 pi over 3. And remember, each time you graph your parent functions, you're going to graph your 5 points. So we're gonna start with 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and 2 pi 0. I just graph the sine of x. So I graph cosine of x. I'm starting at 1, 0. Pi over 2, 0, pi negative 1. 3 pi over 2, 0. And 2 pi 1. Include those additional points. Remember, this is a nice little curve here. Okay? So for what value of x in radians is sine of x equal to 0, we're going to have 0, pi, 2 pi, and 3 pi. All as that cycle keeps going. Okay? So you don't have to start working on the practice yet. Just make sure you have filled out the notes and make sure you have watched not only this video, but also part 1 as well. And I'll see you soon.